Hello everyone, welcome to BC 2402. As you know, this is week one and we do not have face-to-face session. The reason is that because we have a public holiday on Monday and we do have classes from Monday to Friday. And if we do miss out the Monday class, then the entire progress of our cohort will be sort of inconsistent. We can certainly do a makeup class, but if you are aware, in this semester, in fact, we will be having another public holiday in subsequent weeks. So as a result, it's actually quite difficult for us to make up for the missed session if we do have a face-to-face session in week one. And also the university is encouraging online or electronic learning. So we have taken the decision that for week one, we are going to take it slowly and easy by giving you some general introduction to relational databases as our first session, which is now conducted online. As far as possible in this course, I will try to make some videos to better illustrate our point to you. And we'll be making use very heavily using all the online platforms. Now, so let us begin today's session. Okay, so for today's agenda, I will first of all give you a general introduction to this course. I will also tell you about the course overview in terms of the content, mode of instructions, and course assessment. And we will touch on a little bit with regards to introduction to databases and development. At the end of this video, I hope you can also watch the video that I have included that is about introduction to databases. Okay, that video will actually give you slightly more content and let you and make sure you're better prepared for the coming weeks. So the objective of this seminar is to help us to start to know each other, or more specifically, to allow you to know a little bit more about this course. It is very important that we set our expectation right, all right, so that you have the mental preparation going forward. And I will give you an overview to this course. And finally, for the last part of this discussion, I will introduce you to databases. So let us begin the introduction. So let's talk about the course. In this course, the key learning goal is about learning database design and database management. You will be working on problems or exercises individually and also as a team. So I believe starting from week 2, you'll be sitting in teams in all our flipped classrooms. So it is important for you to form the teams beforehand because we do have a fairly important group assignment in this course. Very importantly, we are teaching you skills to solve problems as well as to make the right decision, or at times to make educated decisions. So you have to keep in mind that there are multiple ways to solve a problem. Likewise, in this course, we are looking at data and data-related problems that we are trying to teach you with some database skills in order for you to handle and resolve these data-specific problems. Presentation and communications are two key soft skills that I can't stress enough. In particular, we are going to assess you through oral and written form. The university is increasingly emphasizing on interactive classroom interaction. So please do participate. We'll have ample time for us to talk, to interact, for you to ask questions, as well as for you to answer questions and discuss. The general content or the general structure of this course is as follows. First of all, we will start with looking at relational database by paying specific focus on the diagram, which is what we call entity relationship diagram or ERD. We also look at normalization, which is the bread and butter of relational database. In terms of the technical part of relational database, we'll be learning a language that is called structural query language. So that is also called SQL. In the second half of this course, which is after the recess week, we will start to look at the more updated or the more recent version of database or database technology, which is non-relational database. In particular, we'll introduce you to some very important fundamentals, namely HBase and Hadoop. Some of you may have heard about this before. And in terms of a technical aspect of this half, we'll be looking at another language, which is called NoSQL. This is actually somewhat related to SQL, which you learn in the first half of this course. And SQL is going to provide you a very important sound fundamental for you to move forward to NoSQL. So to learn your SQL well in the first half, such that you are well prepared to learn about non-relational database design and implementation. Finally, which is our last session before exam, we'll be looking at some general topics that will nicely wrap up these two key ways of handling data-specific problems. We will be talking about data governance and some other ethical issues. If we have time, I will try to introduce you to yet another language, which is called NewSQL. And of course, we will talk about exam then. In terms of assessment, this is the general assessment format. I will give you an update in week 2 when I present you the course outline. But in general, we have team assessment and individual assessment. Team assessment is essentially the semester project, which is going to be handled by your group. And in particular, you are supposed to develop two databases over the same problem. So the first database is relational database, and the second database is going to be the non-relational database. I'll be sharing with you some concrete information later. And the second important component of assessment is individual assessment that gives you the remaining 70%. Class participation is going to earn you 20%. So do actively participate in your class discussions and exercises. We also have e-learning and quizzes on a weekly basis. In fact, for today, we also have a online quiz, but it is not going to be graded, just to make sure that you are running in nicely into this course. So take it easy and enjoy the interactive platform on NTU Learn. And the final bit of this puzzle of assessment is our final written exam, which will give you the remaining 40%. As you know, all the courses that's being conducted by the business school in NTU utilize the flipped classroom environment. So you're expected to be prepared before attending classes. All right. And it is your responsibility to get prepared and come and discuss and get involved in working through the class exercises. Okay, so we will be adapting the cooperative learning approach. You will be sitting in small teams, and it is expected that each one of you will have slightly varying level of ability to learn individually, but collectively we do expect that there is a good complement among each of you in a team. So the environment is specially designed in the flipped classroom to allow collective achievement. And we are trying to focus on fairly interactive approach in which at the team level, we do expect you to be able to clarify problems among yourself, to ask each other questions, and to be able to summarize based on the discussions that you have. And I will be walking around when we get to see each other face to face starting from week 2. After each of the class exercises, I will be sitting down with each team to give you immediate feedback. So the role of me, as well as my colleague, is to facilitate and to learn and to monitor the learning process. And more importantly, we are trying to build on the materials that are given to you and not really spoon feeding you. This is a very important skill that we hope we will be able to learn. Okay, so in each seminar, essentially we will start with a content review. So we will touch on the slide deck that we will be releasing to you in advance. We will be following by some in-class exercises and discussions, and at times we may have some other activities. We might be doing this in multiple trunks, meaning that we may cover a little bit of content, then we do some exercises, and we go back to covering content and go back to exercises interchangeably. So that hopefully this will be able to better maintain your focus. This course require you to draw some diagrams, in particular the first half of it, when we get to learn entity relationship diagram. So there are many software applications that you can use to draw this diagram. For example, Microsoft PowerPoint. I'm very sure you have a copy of it because NTU does provide to Microsoft or the Office 365, which includes the Microsoft PowerPoint application. It is very easy to use. Basically, you can draw all kinds of diagrams, but yet it doesn't include any templates that are specific to our purpose. So in this case, you will need to work very hard at the beginning to build the templates on your own. The other possible software application is Microsoft Visio. It is a very popular commercial tool. In fact, if you go to companies, very likely they will be using it. Some suggest that this might be somewhat difficult to use, but my personal experience, well, I find that it's easy because perhaps this is the first application that I have learned in diagramming. It can't do everything that we learned or we want in this course, but it can do most of it. And of course, there are some others which are freely available online. So when we get to the sessions that we will be looking at diagram, which is in fact next week, I will be giving you a little bit more materials with regards to what are some of the software applications that we can use. This course is about database, so you will need to install database applications on your machines. There are many different kinds of database applications available, for example, Microsoft Access, Oracle, MySQL, and so on. For this course, for the very first half, we will be using MySQL. I will be giving you very concrete instructions to guide you through how to install, not just install, but download and then install MySQL on your machine. You will see that I'm using a Mac, but actually I'm a Windows user. So if you look closely, I'm actually running Windows 10 on my Mac machine. So for those who are using Mac, I will try my very best to help you if you shall encounter any problems installing MySQL, for example, on your Mac. But do pardon me because I don't actually use the Mac OS. In terms of textbooks, I have prescribed you one key textbook for this course, but that's not sufficient. So we'll be giving you additional materials to keep your cost in attending this course reasonable. So we do expect that you try to get hold of the main textbook. Please do refer to the course outline or NTU Learn with regards to the details of this main text that I have prescribed to you. Okay, this textbook is good largely for the first half of this course. For the second half, when we get to touch on non-relational database as well as NoSQL, the materials that's available in this textbook will be slightly limited. So we'll be giving you some additional materials then. So how do you survive this course? You probably have learned from your senior that this course does involve quite high workload. And in fact, in this year, we have quite heavily restructured the course. So in the past, we do not really include the non-relational database portion. So the second half of this course is completely new. But I'm very sure you'll find it very useful to you. The important is that you have to work consistently. To remember, it is going to be fairly challenging if you try to just prepare for this course towards the exam. Likewise, for your group assignment, if you only set aside the very final week before the deadline, very likely you'll be running into problems. So as far as possible, to try to follow the progress of our seminar, if not running slightly ahead, that will certainly put you into the upper hands. All right, so let us look at the specific outcome of this course that we do expect you to be able to acquire. So here you see a fairly complex diagram. So pretty much this is a design of a database. More concretely, this is the design of a relational database. So we do expect you at the end of this course to be able to understand the key components in relational database as well as non-relational database. So specific to relational database, we do expect you to understand what tables are, what tables have, which are rows and columns. We'll be coming back to all these topics in more detail soon. And more importantly, how do you uniquely identify each of the records or each of the rows in a relational database? What are tables and how do tables work together? And overall, we are essentially trying to use relational database approach to resolve some data problem. So ultimately, what you'll be trained to do? Well, basically, we are trying to train you with some real-world skills, which is problem-solving skills. And this skill in particular is a database-specific skills for you to handle as well as to resolve any data-specific problems in the business environment. So to do so, you must understand what the clients or your user needs and how they understand and use data and how IT professionals actually developed an actual database to support organizational decision making. It is important because a database is just a structure to contain data. It is only meaningful if you understand the underlying business logic or business rules. By having such an understanding, then you can do meaningful analytics and hence derive executable insights. All right. So basically, this is very, very hands-on. This is very, very practical. Okay, and this course gives you very high real-world value. All right, for those who have actually watched the video materials for week 1, you can go ahead to actually do the check-in quizzes on NTU Learn. You can also wait until the end of this video and read the textbook chapter, and then when you're ready, attempt the check-in quiz. Once again, the quiz for week 1 will not be graded. Okay, so let us now start our discussion formula. Now we know we are going to look at database, but in order for us to understand the context in which the database is sitting in, we need to understand the information system in general. So this is going to be quite straightforward, I hope, to most of you. Here you see the value chain, which is proposed by Porter some decades ago. Now, it is still meaningful to us because the value chain model essentially tells us that there are two kinds of activities, namely the support activity as well as the primary activity that are always relevant to any organization and businesses. Primary activity essentially are activities that are about generating value for a business or an organization that largely include some input, some internal processes, and some output. Support activities are not the core business or the core activities of the organization, but those are essential because without support activities, the company simply cannot function. For example, human resources. We need that activity in order for us to manage our people. Purchasing and procurement. You need such an activity in order to facilitate inbound logistics, for example. And of course, we need technology. And more importantly, if you look at the bottom of this slide, we have an industry value chain. So a specific focal company doesn't sit isolated. Rather, it is actually coupled with some upstream businesses as well as some downstream businesses. So in this case, it's very likely this particular company is working with some supplier as well as distributor in terms of its inbound logistic and outbound logistic activities, respectively. So just now I have emphasized on primary activities. So on this slide, I give you slightly more details about each of these activities. I will let you to read this slide on your own, but do keep in mind, each of these activities do involve data, be it generating data, collecting data, inputting data, or outputting data. So here, through all these primary activities, we'll be able to collect a lot of data that are vital, okay, to the conduct or the continued functioning of the business. So it's important for us to design a database correctly that support all these activities. All right, so this slide essentially repeats whatever that we have talked about previously. But once again, I would like to focus on inbound logistic and outbound logistic. As I have told you earlier, inbound logistic activities are essentially the activities between suppliers and firm, whereas outbound logistics are about the activities that take place between this firm as well as some distributors, for example. So essentially, this tells us that the data that are being collected and used within this firm might be involving other companies and organizations. For example, logistic data that are important to not just this particular focal firm, but also the supplier. Likewise, for outbound logistic, we need to pass this data to the distributor in order for outbound logistic activities to occur. Well, in this slide, we are trying to enforce on the importance between information system and businesses. So basically, they are closely coupled. And this actually implies that data is only relevant and meaningful if we also observe this interdependence between business and IS. So effectively, whatever data that we have captured in the database must have business meaning or must have business value. All right, so this is about a general definition of information system. I'm quite sure you know this quite well. So I will let you read, okay? This is not really the focus, but this serves as the background understanding of this course. All right, so if you look at a general information system, typically it involves some input and some output ultimately. In between, we have to process whatever data that's being passed into this system, and we will push out this data probably in some formatted forms as output. And this processing typically involves some storage, probably a hard disk, and in our context, it's about storing the data in the database. So one does not simply get data for analytics. Essentially, it is a garbage in, garbage out story. If you do not get the right data for analytics, your insights are very likely going to be fairly meaningless. So the emphasis is on data. Okay, so what is data? Well, data is in fact some raw facts about people, places, events, or anything that are important to an organization with some business sense. When we transform this data by bringing in some meaning, typically it is some business logic, it becomes information. So essentially, there are data that has been processed or reorganized into some meaningful form, then it is information. And finally, when we infuse all this data and information together from multiple sources, then we will have knowledge, which is to bring in the context. So for example, here, you just have one chunk of number. So this is essentially just some data. It doesn't have any meaning. But if I tell you this is actually a NRIC number, this gives you some information because this is essentially a piece of information that allows you to identify a particular individual. So if additionally, apart from this NRIC number, I bring in some other additional information about this individual, for example, age, gender, and place of birth, as well as occupation, that probably will give you sufficient contextualized information for you to derive some knowledge. So you know that, oh, this particular guy, he is now working in NTU and he is teaching this particular course, which is BC2402. Now, in order for us to have meaningful analytic insight, we have to keep an eye on the data quality. There are many ways that data quality may go wrong, but it's important because with good data quality, we can ensure we are making the right and timely business decision. So what are the characteristics of quality data? There are many different aspects of quality data. I have listed some important ones here. For example, we must make sure that it is accurate. We must make sure that it is consistent. As far as possible, we would like it to be timely. Finally, referential integrity is a very special form of data quality or characteristics of quality data that's relevant to relational database. So we'll get into the details about what is referential integrity in future discussions. So what are the causes of poor data quality? Well, there are many ones again. It could be human error. Sometimes this is because of poor design, that the database is designed in the wrong way. Sometimes it's because multiple databases are not working in a coherent manner, and that creates redundant data storage and inconsistency. At times, it is actually a company issue or a governance issue because there's no organizational commitment in terms of clarifying or ironing out all this inconsistency, and those inconsistencies just remain and result into very poor data quality ultimately. So there are many ways, once again, that we can actually improve data quality. It is getting more and more common that there are data quality audit because company increasingly recognizing data is actually a very, very valuable asset, if not a strategic asset to some companies. Oftentimes, this audit involves looking at the data capturing processes. So as far as possible, we try to remove manual processes. We try to automate it. If not, we try to ask the very end user to actually do this data entry process themselves. And that's why when we are doing all the registration on our own. You do not, very rarely you will have to fill out a form, and this form is passed to some data entry clerk, and your data or your information is being entered into the system by another person. The rationale behind this is that we are most likely be able to provide accurate information that's about ourselves. For example, our name. Very unlikely we will spell our name wrongly, but if you ask someone else to key that in, the likelihood is much higher. All right, so there are many more mechanisms that can help to improve the data capture processes. So when we look at the system as a whole, we have to make sure our system implementation can support all this as far as possible to ensure high data quality. At the governance level, at the company policy level, we can also implement data steward. Essentially, it is someone who is responsible, or more importantly, to become accountable for the way that the organizational data is being collected, is being captured, and is being protected. So this person very likely will be enforcing data governance, which are essentially some established policies that the organization has to follow in handling all the data and data-related processes. So here are some of the very common principles for high-quality data models. We're looking at data model in week 2 when we look at ELD and some other models. And I will be formally introducing you entity. So for today's discussion, entity essentially about objects. So you can imagine student is an entity in this relational world. A instructor is an entity. A university is an entity. BC2402, this course can be modeled as an entity as well. And there will be activities and associations that are represented by these entity types. So basically what I mean here is that each of these entities are related to each other based on some relationship. So you can imagine me as an instructor, I am teaching this course, which is BC2402. So BC2402 as a course is an entity, me as an instructor is an entity. So the relationship between me and BC2402 is teach, all right? Need not worry too much because we will be getting into the details of it, but we will have to follow a certain data modeling methodology that will allow us to ensure high quality data. So basically, in the first half of our discussion, in this semester, we'll be looking at using relational data model to ensure high data quality, whereas in the second half, we will be looking at non-relational data model, which is fairly flexible. Now, the next important bring away that I would like you to remember that applies to relational database is what we call ACID. So this is a very important property that ensure data quality in relational database. And to an extent, non-relational database also try to observe as much as possible these properties, but they do make a trade-off. So there's a very interesting topic when we look at both relational database and non-relational database in terms of how much they follow or how much they implement this ACID property. So what is ACID? ACID, A, stands for atomic or atomicity, which essentially means that a transaction cannot be subdivided. If you think about an ATM machine or an online banking, online cash transfer, for example, this particular transaction has to be atomic. You can't have this transaction half done and hanging there. If I transfer you $10, that means $10 is transferred. It can't be 5 and we just wait. Consistency, that is for say, essentially means that constraints don't change from before transaction to after transaction. Okay, so essentially that means that the data remain consistent before and after a transaction. So when a transaction has completed, the database has to remain consistent. For example, if I'm transferring you $10 before the transaction is done, okay, I have $100. After the transaction is completed, I now have $90. Okay, and it is consistent because the $10 now goes to you. It didn't disappear in thin air. Isolation essentially means that database changes not relevant to users until after the transaction has completed. Okay, so imagine once again in my bank account, I have $100 and I'm trying to transfer you $100. All right, and when this transaction is happening in progress, imagine it takes 10 seconds to complete. When 5 seconds has passed, I cannot perform an additional transaction because of isolation. So basically, I'm frozen out. This particular transaction has to be completed before I can carry on the next transaction. What is the rationale? Well, the rationale is to ensure that I cannot double draw from my account. Okay, otherwise, when I'm transferring $100 to you, in that 10 seconds that was required for this transaction to complete, I may actually make an additional $100 transfer to you. Then in such a case, I have $200 that I can transfer to you magically. Durable or durability. Essentially, it means that whatever changes that's made to the database will remain permanent. So after I've transferred $10 to you, that particular $10 transfer is permanently written into your account. And the deduction of $10 from my account is also permanently written. All right, so those are essentially databases. So let us move on to the basic of the database. So here in this slide, I explicitly show you the comparison between data and information. So data is on the left, information is on the right. So data are in fact just raw materials, or what we call raw facts. It has not been processed to reveal their meaning to the end user. It could just be numbers, alphabets, and symbols. These are the basic building blocks or ingredients for us to build information. So in fact, in terms of data, we're interested to look at data management, which is about how you generate this data, how you store it, and how you facilitate retrieval. In terms of information, when you process data or raw data with its meaning, then this is information. So in order for us to do so, we need to know the context. So just now I say $10 transfer from my account to you. So data basically just 1 0. Okay, from one account to another, which are just two sets of numbers as well. It doesn't mean anything, just a set of numbers. But when I put it into a context, which is cash transfer, then that actually gives you some meaning, and this is like information. It forms the bedrock of knowledge. So probably by looking at collectively all the customers in this bank in terms of their cash transfer among themselves, we might be able to identify some fraudulent activities. All right. So this is essentially knowledge. And we have to make sure this information is accurate, relevant, and timely in order for us to make good decisions. All right. If the information is inaccurate, for example, instead of reflecting $10 transfer, it will reflect $100. All right. It will not allow correct understanding in terms of this cash movement scenario. So formally, I'm now introducing you to databases. Essentially, it is a shared integrated computer structure that helps us to store a collection of data, in particular end user data that's of interest to them, as well as metadata. So metadata is essentially data about data. We'll come back to this when we look at specific database implementation. So it is important to store data, metadata because we need metadata to describe the data characteristic as well as the relationship among tables, entities, and so on. So the software application that help us to manage database is called Database Management System, or DBMS. So it's effectively a collection of software programs that help us to manage not just the structure of this database, but also to control access to all the data that we have stored in the database. So what does it do? Well, basically, it is the layer that is sitting between human user and the database that's probably sitting in a computer. It enables data to be shared. So we might just have one single machine in the machine there's just one single instance of a database, but all of us can actually use it. Just look at NTU Learn. It is sitting on one single machine with one single instance of database, but all of us can log into NTU Learn concurrently. Basically, it helps us to see, as an end user, an integrated view of the data. So on NTU Learn, once again, you see very nice, meaningful, relevant, understandable presentation of your course data. Okay, you do not see it in the raw form. And it helps to receive and translate application requests into operation required to fulfill the request. For example, when you are submitting your quiz answer, so this is a application request, which you are essentially requesting the machine, which has the database, to store your quiz answer. It hides the database internal complexity from the application program and, more importantly, to user. So as NTU Learn user, we do not see the actual structure of the database that are capturing and storing our course material data. So here is a graphical representation of a database management system and the entire usage environment. You can see that the database management system is actually sitting in the middle that facilitate interaction between human and user with the database, the actual database itself. So there's some database structure sitting on some kind of storage, maybe hard disk or some other kind of solid form storage, and that store our actual ones and zeros essentially. So why are we using DBMS? Well, because it does a very good job in terms of integrating data and ensuring there is very minimum data inconsistency. So basically, data inconsistency is that there are many different versions of the same data appearing in different places. So try to recall our cash transfer story just now that I'm trying to transfer you $10. Okay, when data consistency is enforced, I should have only one single copy of my remaining balance. So be it $100 before the transfer or $90 after the transfer, there shouldn't be more than one copy of my account balance. By doing that, it actually helps us to increase end user productivity. Otherwise, we will be tied down with all this problem in the data. It does improve data sharing, security, access, and decision making. So overall, it helps. It is very, very helpful in DBMS to enforce data quality in terms of accuracy, validity, and timeliness of data. So there are many different types of databases. As I've earlier told you, there is SS, there is MySQL, and so on. SS, Microsoft SS, is a single user database to a large extent, and it typically runs on a desktop. Multi-user databases allows support multiple users concurrent access very well. So typically it sits on some kind of servers or the cloud. There are also many, many other types of the databases, which I will not get into details because in general, we'll just take two forms in this course, which are relational and non-relational. Of course, there are some special kinds of databases that are designed for analytical purposes. Essentially, in order for us to conduct analytics, we're interested in large-scale historical data, as well as some business metrics that are used to make business decisions. So there are some database concept which has been around for quite some time to facilitate these analytical processes, namely data warehouse and OLAP. All right. For details, I will advise you to read the textbook or watch the other video, which will give you very detailed explanations. Overall, by implementing all this specific database design, what we want to derive is business intelligence, which are insights to help the business. In terms of data, there are many different forms. There are unstructured data, which means that this is data that exists in its original state. The other form is what we call structured data. So basically, we have gone through some kind of formatting. When we go through formatting, essentially, we are converting unstructured data into some structured data. There's also semi-structured data, which means that the conversion from unstructured to structure is not complete. We only convert to an extent of those due to whatever reason. And finally, extensible markup language, XML. So in relational database, we'll be looking at structured data largely. And in non-relational databases, we'll be looking at unstructured as well as a version of the extensible markup language. So what is database design, which is one of the key focus of this course? Essentially, it is about implementing some database structure that are used to store data and to manage end-user data, which is the metadata. It is important to have well-designed databases because it facilitates sound data management that will allow accurate and valuable information to be generated. When it's poorly designed, basically we have very poor data quality, and this data will not be useful. If you look at history of database, how does it come about? Very, very long time ago, I guess it is about 4 to 5 decades ago, when there's no database, effectively we are using some manual file system that you have huge you have some huge storages of a lot of physical paper files at times, and we need to dig through all these files in order for us to retrieve your record. I guess in like clinics that we can see in neighborhoods, it's getting less and less common that they use this kind of paper file system. Most of them have already implemented the electronic health record system. Anyway, we computerized this file system, so we digitize them, and finally, we actually turn that into some kind of databases because it actually will bring much better end user productivity. So there are many problems with file system. For example, it is difficult for us to share when you have just one single paper file. And when multiple people require these files concurrently, it is quite impossible to fulfill this requirement. So these are essentially the problems with file system data processing. Oftentimes it's very complex. It's very difficult to get quick answers. Just imagine that you need to physically go and dig out the file. It lacks security and limited data sharing because it's quite difficult to actually trace who is holding on to that physical file. And there's just one copy of the physical file, so sharing is quite impossible. Next, we look at structural and data dependency. So structure, essentially, we are interested in look at in structural dependency, which means the access to a file is dependent on its own structure. So basically, all file system programs are modified to conform to a new file structure. So this is bad because effectively that means that if you want to update, for example, a mobile app, for example, Grab 1.0 to Grab 2.0, you need to redo your entire file system. All right, that is not something that we want. We want to separate the file system or the database with the applications that we have developed. So whatever versions, whatever updates that you are going to do on your mobile app, it shouldn't affect the way that the database or the file system or the file structure is implemented. And that's what we call structural independence. So basically, the file structure can be changed without affecting the app's ability to access the data. So whatever changes that Grab is doing on its backend database, it will not require immediate changes on the app because it's separated. Likewise, if they are changing the app, it doesn't really require changes to the backend database. All right. Next, I would like to just very quickly talk about data redundancy. So in data redundancy, basically, it is about unnecessarily storing the same data in different places. And when you have such multiple redundant data stored all over the place, it will create a lot of problem. For example, imagine your mobile number is stored with NTU at multiple databases. So I keep a copy of your mobile number on a spreadsheet. The business school keeps a mobile number on their own spreadsheet, and NTU at the registrar level keeps a huge spreadsheet of each one of your mobile number. And you have changed your mobile number because the new iPhone has just launched, and you notify me. So I will do the changes, but business school will not do the update. Likewise for NTU. So this will be problematic because they will be holding the wrong mobile number for you. And that's what we call islands of information. All right. So the implications is that you will have data inconsistency. That's exactly what we've just discussed. When you do changes, your changes of mobile number might not be correctly reflected across all the different redundant storages. It also will enable poor data security, because if we just have a centralized location of storage, it's easy for us to guard against any malicious attacks or unauthorized access. But when you have multiple, we don't know where that spreadsheet is being circulated to. All right. Next, I would like to look at data anomaly. So data anomaly are essentially problems that can be created because of data redundancy. So just now, the update of mobile phone number, in fact, is an example of update anomalies. So when you update your mobile phone number, it might not be reflected across all the different redundant storages. Likewise, for insertion anomalies, for example, now you buy a second handphone and now you have a second mobile number and you only notify me. So once again, business school and NTU will not be able to insert this particular record for your new mobile number. Finally, deletion anomalies, which is about removal. So if you have decided that, well, I am no longer using the second mobile phone, I would like to delete it from all the records. In this case, you notify NTU, you notify business school, but you forget to notify me. So in such a case, on my record, I continue to hold your second mobile number. And this is what we call delete anomaly. All right, so databases, once again, are essentially logically related data that are stored in a single logical data repository. Although physically it could be distributed among multiple storage facilities, meaning that you can use multiple hard disks, for example, to store one single piece of database to speed it up. The current generation of DBMS are very, very powerful because they can actually manage everything for you. So you need not do a lot of this database management activities manually. So these are the list of key functions that you can find in DBMS. For example, data dictionary management that essentially store the definition of all data elements and their relationships. So this is actually storing metadata. Data storage management will be about performance management, which is about how to allocate your data across multiple hard disks, for example. And of course, security, transformation, presentation, user access control, backup, and integrity management. All right. Next, we look at languages. So database can be accessed using some languages. So effectively, people can talk to the database directly using some languages, and in particular, structured query language or SQL. This is the de facto query language and data access standard that's supported by majority of DBMS vendors. It is a very old language actually, but it is one of the most important fundamentals in terms of database access language that you will need to learn, because with sound and concrete fundamentals in SQL, basically you can learn any other new forms of languages, okay, but not the other way. Okay, there are still majority of the system or the databases in the market that use relational database because it focuses on transaction. Just imagine you buy things online on Amazon Prime, it's a transaction. Very likely, somewhere within Amazon, some of the databases are relational. So we will need to know how to talk to relational database using SQL such that you'll be able to retrieve and synthesize insights, okay, by performing business analytics. There will be many different ways that you can communicate with these databases through various interfaces. So in this course, we will be learning MySQL Workbench, which I will introduce you formally in the future. There are some limitations, of course, in using database system. In particular, is the cost. Now, of course, we are introducing you to the free version of MySQL. But if you are coming from a business or a actual company point of view, you have to pay for it. You have to pay for the license, which is not entirely cheap. Database can get quite complex, so the management of it requires specialized personnel, for example, database administrator or some database specialists. It is also important to maintain currency, which means that you need to go for updates to patch it, and as a result, you are essentially vendor dependent. Okay, and oftentimes you need to replace it after some cycle, be it replacing the software or more commonly replacing the hard disk, because it will fail eventually if you don't replace it. So that's all for week 1, very quick discussion. So next week will be week 2, and we'll be looking at process and data modeling. In particular, I will be introducing you entity relationship modeling as well as extended EL modeling. Sorry about the spelling, it should be modeling. I will fix that up later. In week 2, when we get to see each other, I will then formally present you our course outline. We'll talk through each of the important items in the course outline, as well as introduce you to the software that you can use to draw all this diagram. Till then, take care, and I shall see you.